Sashikal students. So today we are going to discuss the second law of motion, and we are going to have mathematical formulation for this. And we are also going to understand that second law of motion defines what? It gives us definition of something. What is that? Okay. Now according to second law of motion, let me state this law. It states that the rate of change of momentum, what? Please speak, students. The rate of
The rate
Change
of
of
change of
momentum.
momentum
change of momentum of an object of an object. The rate of change of momentum of an object is proportional to the applied force in the direction of force. So there are so many things, students, in this, and I will take everything one by one. Number one, it's talk about momentum. Let's understand what is momentum. So I will write here momentum. Right? Students, momentum means, suppose this is a table, right? And on this table, let's say there's a ball. The ball is, you can say, rotating or whatever it is. The ball is moving, with velocity v, and m is the mass of the ball. This is a ball. This is the object. Okay. So v is the velocity. What is the unit of velocity? Meter per second. What is the
Second.
unit of mass? K, small k, g, kg. Now, the product of momentum is represented by P. Momentum is represented by, it is basically the
P.
product of mass into velocity. So I can say P is equal to mv. So Monrose, what will be the units of momentum? It will be kg meter per second. This will be the momentum, a unit of momentum. Okay. Then it says change of momentum. What is the meaning of change of momentum? When the momentum will change? Can any student tell me when the momentum of an object will change? See, if it continues to move with velocity v, its momentum will not change because mass
change.
ma- will not change. Beta, don't say change. The mass of the object is always remaining constant, right? The mass is always
Yes.
and if the velocity is
Constant.
constant, then the momentum will be constant. Then can any student tell me when the momentum will change? The momentum will change when the P will change, when the velocity will change. Am I right? And how the velocity of object will change? How the velocity of object changes? No, speed and velocity is same. When the velocity of object will change? According to Newton's first law of motion, if external force is not applied on an object, its velocity will be Constant.
Same.
On moving, same. Then when the velocity will be changed? Velocity will be changed if I apply some force
Force.
on the object. Is it right? Either I apply
Yes.
force in the opposite direction or I apply force in the direction of motion. In both the cases, direction of motion. In both the cases, the velocity will change. When? Once again, when the force is applied on the body. Am I right? Let's say your car is moving with 60 kilometer per hour, right? Then suddenly when you press the accelerator, when you press the race, students, please switch off your mic. When you press the accelerator, the car starts accelerating. The velocity of the car increases. Why? Because engine is applying force on the car. So the velocity changes. So velocity will change from 60 to 80 kilometer per hour. When the velocity changes, the momentum will also change
change.
because momentum is equal to mass into velocity, right? Okay, now students, I have explained you all this. Okay, now see, sorry, see students, now let's say a body is moving with this is a ball, it's moving with initial velocity u. What is u? U is the initial velocity of a rigid body. I will take a rigid body. Okay, now I apply some force F on this. We all have agreed that if we apply force, then only the velocity of the body will
Change.
change. Okay, so
Change.
let us say we are applying force for time t. You see, force is always applied for some time interval. Am I right? Like maybe मैंने किसी को धक्का मारा, तो धक्का मारा मैंने 2 सेकंड के लिए, है ना? या धक्का मारा 10 मिनट के लिए, या धक्का मारा मैंने जस्ट उसको हिट कर दिया 1 सेकंड के लिए धक्का मारा. So force is applied for some time. Let us say force is applied for time t.
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 As a result of application of force, the now force is applied in the direction of motion. This is the direction in which the body is moving. In the same direction, I am applying the force. So what will happen? The u will change to v. V will be more than u. Why? Force is there, right? So u is the initial velocity of the body, and I can say the initial velocity of the body changes to final velocity of the body. Let us say v is the final velocity of the body. Why the velocity changes? The velocity changed because of the application of,
Force.
Force.
right, for time.
Force.
For how much time? For how much time? I have applied the
T.
force for how much time? T time. Okay. T time. Let's say there is a car. You can apply force on car for some time. Okay. Okay. So now let us read again. What was the statement of second law of motion? Yeah. Pranav, please read the statement. I think you have written. Any student can
So
read the
second
statement.
law of motion.
बेटा वही कर रहे हैं आप कोई थर्ड लॉ या फोर्थ लॉ थोड़ा कर रहे हैं प्लीज बी
The rate of change of momentum of an object is proportional to the applied force in the
That's all.
middle
That's
of
great.
the direction.
So we know what is momentum. Now we know what is a change in momentum. Can any student tell what is the change in momentum in this case? What is the change in momentum? Any student can tell? Change in momentum means final momentum minus initial momentum. So you see, the mass of the body is always same. Momentum, Manpreet, is equal to, what is momentum? Mass into velocity is momentum. So students, what is my final momentum? M. Anyone can say what is final momentum? V is the final velocity. So what will be final momentum? M into V,
F
not F. M into V. F means final. Minus what is initial momentum? What is the
U
U is the velocity, initial velocity. I am asking, what is the initial momentum?
M into U.
Correct. M into U. So what is change in momentum? Final momentum minus initial momentum.
Initial moment.
So I
initial
can say
momentum.
this is equal to, can I take M common? Can I take M common? So it is V minus U. Good. I got change in momentum. But Newton's second law of motion say rate of change of momentum. It is not talking about change in momentum. What is change in momentum? Mv minus mu. What is rate of change of momentum? Can any student tell me? Rate of change of momentum. Can any student tell me? Beautiful. Manrose, you are right. Whenever this rate comes now, like in power, the rate was there. Power is rate of doing work. What is rate of doing work? Work done divided by time. That is joule by second. This is known as what? Rate of change of momentum. First you write what is change in momentum. Change in momentum is m into v minus u divided by in how much time duration the force was applicable. The force was being applied for
T.
t seconds. So that,
T.
correct. So that in that t second, the initial velocity u changed to final velocity v.
V.
What is the change in velocity? Change in velocity v minus u. And what is the change in momentum? Mv minus mu. So what is rate of change of momentum? M into v minus u by t. Okay, now Newton's second law says this rate of change of momentum is proportional to. See, we want to have a mathematical formulation. That means whatever is the statement, we will express that statement in units and mathematical notations. So this is proportional to what? Read the again. I want this time Falgun Kaur to read the statement of second law of motion again. Everyone listen carefully.
Yes, sir. It states the rate of change of momentum of an object is proportional to the applied force in the direction of force.
Correct. You have not written one word unbalanced force. But anyway, forget about balance and unbalance now. Some force is there. So it says M into V minus U divided by T is proportional to F. F is the force which has been applied on the object whose initial velocity was U and in time t whose final velocity increased from u to as a result of
V
application of force. What? Which force? F. How much force? F. Very good. This
F
is this is Newton's second law of motion, but it is not complete. Let's go to second page. So it says the rate of change of momentum, we know what is rate of change of momentum, V minus U divided by T is proportional to the applied force. But we want to have an equation. We want to have a, if you want to have an equation, you have to get rid of, this is proportionality, sign of What is this? This is
Ultimate.
sign of proportionality. Please switch off your mics. Sign of proportionality. See, human beings, you have to only tell once, but if it is donkeys, you have to tell again and again. You have to apply stick. This is sign of proportionality. This means this rate of change of momentum is directly proportional to force applied. Now, you know, students, whenever we want to remove this sign of proportionality, we have to introduce a, any student? We have to introduce a constant. So the constant of proportionality, let us say that is m into v minus u by t. F is equal to k into this. See, I've introduced a constant of proportionality. K is constant of proportionality. What is constant of proportionality? I will tell you. Suppose students, one side of triangle is 4 centimeter. Other side of triangle is, let us say, 8 centimeter. Please listen carefully. I will tell you what is the meaning of constant of proportionality. Somebody says these two sides are in the ratio of 1:2. Is it right or wrong? These two sides of the triangle are in the ratio of 1:2. Is it right or wrong? It is right. But
Yes, sir.
but 1 and 2 are not the actual measurement of sides. Actual measurement of side is 4 and 8. Now, what is constant of proportionality? Can anyone tell here? Can anyone tell what is constant of proportionality? Constant of proportionality is 4. That means if you multiply 1 with 4, and if you multiply 2 with 4, you will get the actual sides. And actual sides will be 4 centimeter and 8 centimeter. Right? So K is constant of proportionality. So I can say F is equal to K into M V minus U by T. But students, the unit of force is taken like this. It's taken 1 Newton. Unit of mass and V and T are taken in such a way that K ultimately comes out to be 1. So I can say goodbye to K. I can simply say F is equal to M into V minus U divided by T. Now students, come very interesting part. Students, can anyone tell what is the meaning of V minus U by T? Yes,
Acceleration.
correct. Because V minus U is change in velocity. Change in velocity divided by time is equal to acceleration.
Rate of
Acceleration. So this is a double C acceleration. So I can say this is equal to m, mass of the object, into its acceleration a. Students, from this I got a famous formula. F is equal to m a. You got it? You got it, students?
Yes, sir.
Wow,
Yes, sir.
that's a voice like Monroe's. F is equal to ma. Okay, students. Now, from this comes the important thing. I told you today we will discuss what definition we understand from second law of motion, and that definition is the definition of force. See, students, when I started lecturing on this subject, I told you force before second law of motion was, people were not able to measure force. It was only after second law of motion that people were able to measure the force. Force is equal to mass into acceleration. Suppose in SI units the mass of the object is kilogram, and in 1 kilogram object is there, 1 kilogram object, I apply some force so that it is accelerated by 1 meter per second square, or it is decelerated. Decelerated means negative acceleration by minus 1 m by meter square, I say the force applied is is said to be how much? Any student? When the mass is 1 kg, acceleration is 1 unit, then the force is said to be, any students? 1 Newton, because this law was given by Newton. So in his honor, we gave unit of force as Newton. Students, do you like the channel? Learn CBSE. Stay with us. Grow with us. Wish you all the best. Thank you.